codominance. We've actually already talked about codominance a bit with blood type. We're going to go into a little more in depth in this set of notes. So the first thing that we need to do, put our name on our paper. Okay. Now, with codominance, this is a pattern of inheritance with more than one allele that is dominant. And therefore causes effects on the organism's phenotype. Remember, the phenotype is what you see. So there's going to be more than one allele that is dominant to the point that it impacts what you see. So the best example here of codominance is blood type. So we've got two alleles, IA and IB, that are codominant with one another. Whereas allele I, and just to be clear, this is a lowercase I here. The printing makes it such that it's a bit hard to see that the dot is separated, but it is in fact a lowercase I. The little I is recessive to both IA and IB. So we're going to do an example here. We have a man with an IB little I genotype. Remember, this is a little I. Who marries a woman with an IA little I genotype. And she gets pregnant with their first child. We're going to perform the cross. So we're going to make the Punnett square on the right to predict the chances of each blood type for their first child. So what trait or allele is dominant? Well, we just said that we're dealing with codominance here. So with codominance, they're equally dominant to one another. So that means that IA So in this case, we actually have two answers here. We have IA and IB. And what traits do those code for? Well, IA codes for type A blood and IB codes for type B blood. Okay, which trait or allele is recessive? Little I is recessive. Which corresponds to type O blood. Okay, so let's go back to the problem. It says that a man with IB little I genotype. So let's fill that in. He is IB little I. So if he's IB little I, and we know that IA and IB are codominant with one another, but that little I is recessive to both of them. That means that if this man has an IB and a little I, then his phenotype is that he is going to have type B blood. Okay, what alleles does he have? And this is where that comma is required. He has one IB allele. I'm just rewriting that so that it's clear that that's a B. And then he also has one little I allele. Okay, the female said she has IA, little I. So again, IA and IB are codominant with one another, but little I is recessive to both of them. So she has one IA and one little I, which means she is going to be blood type A. Her alleles, she has one IA and she has one little I. So before DNA testing was discovered, and remember we talked about this in class, DNA testing was only discovered in the mid-80s. Before that, blood type was used, but it wasn't nearly as specific as DNA. So now investigators can use DNA markers and modern technology to check whether a man is the father. So Maury can definitively say that with a 99.999% probability, you are the father. And this is by comparing the actual DNA markers. But like I said, before the discovery of DNA testing, scientists knew DNA existed, but before they could test it, all they could really do was compare blood type. Now, with blood type, it couldn't say definitively you are the father. All it could do is exclude a man by saying that he definitively could not be the father. But it could never say that someone specifically was the father. Whereas with paternity testing, DNA testing, with DNA testing and paternity testing, it is possible to say with 99.999% probability you are the father. That's not the case with blood type testing. With blood type testing, all you can say is this combination of mother and father could have produced a child with this blood type or could not have produced a child with this blood type. That's as specific as you can get. Okay. So I'm going to put the father at the top of my Punnett square. There's not a right or wrong answer there. I just decided to put the B blood type the top. Now remember, this person is IB little I. I'm actually going to go ahead and color code that little I. Remember, the biological mother has type A blood. Okay, now we just fill out our Punnett square as we normally would. Remember, we use alphabetical order. Okay, so now let's fill out our genotypic and our phenotypic ratios. So remember, our genotypic are the underlying genes, and our phenotypic are what that translates to, what that codes for. So let's see. We have one case of I'm just going to go ahead and use one color here. We have one case of IA little I. We have one case of IB little I. And we have one case of little I little I. And then we just have to figure out what those, make sure you have your ones there. There's one of each. That's the ratio. That's how they pair out. So if this man who was IB little I has a child with the woman who is IA little I, then they have a 25% chance of having a child with AB blood type. They have a 25% chance of having a child with type A blood type. they have a 25% chance of having a child with type B blood type. And they have a 25% chance of having a child with type O blood type. Okay, thought question. Now, I'm not going to give you the answer to this. I'm going to check your answer here, but I will talk through it for just a moment. So, can a man who is type AB have a child with type O blood? Why or why not? So, you might want to make a Punnett square there. I would suggest making a Punnett square. Okay. You're going to want to ask yourself what is required in order for a child to have type O. So what would that genotype be? And could the man with type AB blood create that genotype? Like I said, you may want a Punnett square there. You have to explain your answer. So a Punnett square would be a way to explain your answer. It's not the only way though, but you have to explain your answer.